Welcome to the Micronaut podcast. I am your host, Sergio Delamo. I am here today with two special guests, Anton Kozlov and Gerrit Grunwald. I hope I pronounce your names correctly. How are you guys?
Fine. Hey.
Wonderful. Hey.
Can you introduce yourself? Let's start with Anton.
Oh, okay. I'm working at Azul in a team that basically concentrated on core OpenJDK solutions, and we do a lot of other things in Azul, kind of prime JVMs that high performance virtual machine with own JIT compiler with custom garbage collector, and a few other technologies to improve startup format and other things. And we also do a few of cloud technologies to help you to analyze how Java is running in your enterprise system. But I'm mostly working on OpenJDK and related stuff.
Can you introduce yourself, Gerrit?
Yes, of course. My name is Gerrit Grunwald. I'm working for Azul as a senior developer advocate, meaning mainly creating content for websites and sessions at conferences. I think that's also the way we met, right? In Barcelona, if I'm right.
Correct, yeah.
And it's mainly about all things we do, like Anton mentioned. So not only the stuff we talk about today, but also other things.
Many people, including me, will probably know Azul from their JDK distribution, but what does Azul as a company does?
Yes, first of all, we build JDKs based on OpenJDK. So that's one thing. And you can get a free build of OpenJDK, which is named Zulu Core, from the Azul website for free, and use it in production if you like. No problem. Then we offer support for this Zulu distribution. Therefore, you have to pay, which is much cheaper than the Oracle stuff, but in principle the same. And on the other hand, we also provide the so-called CPU and PSU updates for this build of OpenJDK, which means critical patch updates and patch set updates. These are the two updates that you can get for OpenJDK that are also provided by Oracle. This is the one part that I would say it's the standard OpenJDK thing. Then we have our own JVM, which is called Azul Prime. And this is in principle based on OpenJDK, but we replace things in the JDK, like the compiler, for example, the C2 compiler. It is part of it, but we also have our own compiler, which is called Falcon, which is an LLVM-based compiler, which has a much better performance. And then we also have another garbage collector inside. It's a so-called C4 collector, which can do pauseless garbage collection with huge heaps in the terabyte size. And also it comes with specific features, so-called Ready Now, which improves startup time. This is the more specified JVM for high-performance solutions, right? Like high-speed trading, stuff like that. And then in addition to that, we also have something called Intelligent Cloud, where we have features like the Azul vulnerability detection, which is something like you might know products like Sneak. They do vulnerability detection on your machine or maybe on your GitHub repository, but nothing is really available that can do this in production. So we bake that into the JVM. So that means because the JVM knows exactly what it runs, right? So it knows exactly what classes to load and what jars open, which classes in the jars are running, and so on. So it calls to a web service, to the Intelligence Cloud, and asks for, or let's say, checks for vulnerabilities. We have a catalog there with all the available vulnerabilities. And so we know exactly if this library uses that class and if it's vulnerable or not, and can give you feedback. So that's the big difference to the other tools that are available on the market, because they can just scan the libraries and see, oh, there is a library that uses this vulnerable thing, but it's not sure if it's really used. You might use a library, but you don't use all the classes in the library, right? So this is the difference here. And then there's also something called Cloud Native Compiler, where we have a compiler grid, let's say, in the cloud that does it's using our high-speed JVM compiler to run optimized code as much as possible. And then you have local instances and that can just put the compilation into the cloud. Once it was compiled in the cloud, it can directly get the optimized code from the cloud instead of compiling it locally, and that saves a lot of time. I think that's all we have, but Anton might know better. So out of my head, I think that's in principle what we are doing. So you see, it's mainly all about Java and JVMs.
Yeah, it's really interesting. We had, I didn't know the security product, and I agree. So we got, for example, so we use a Snake YAML in Micro 3, and Snake YAML is like built-in. And Exchange YAML had a vulnerability if you were like using a constructor, which we were not using. But the problem is the people flag you, right? And if there is no patch, because there is like a Snake YAML provides an alternative solution, and as you say, it's like you are gonna. So if you run like this in your local development environment, you're gonna get like flagged. They're gonna tell you like you have like a Snake YAML which is affected by this CVE, but actually the code is not vulnerable because you are not actually using the code path that is affected. That's really interesting.
That's exactly the problem, right? Because usually these days you have to drag in so many different dependencies, and these again use transient dependencies from other places, and you don't really have an overview which classes are really used. And only the JVM knows when it loads the classes. So that's the reason we built that product. It's quite new. It was I think in December it was published, so it's quite new. You can also find it on the website.
Yeah, I will include a link to the show notes. It's Azul Vulnerability Detections if anyone wants to jump ahead and search for it in Google. In agenda, I'm going to rely on first on Gerrit. Do you have Gerrit is like traveling all around the world, so if you follow him in social media, he's like talks in a lot of conferences. What's coming from you?
I will be at JFocus and talk about JDKs and all the different distributions that we have, because we have, I think, more than 25 different distributions, most of them based on OpenJDK. But what's the difference? Which one to choose and why, right? So nobody knows. Yeah. So mainly people just choose something because they heard of, I use that one because everybody uses it. I try to just explain what's available and with the different features. And then there's another session I will do this year is about security for developers, but not really in deep, because I'm a developer, I'm not a security expert. And it's more or less explaining to myself what is needed as a developer to know about security, right? And why it's important to know something at least. And these are the two sessions I propose to a lot of conferences. So we will see. I don't know where else I will go.
Right now, so we are recording this a little bit in advance of publication, which we are recording this on January 25th. And right now it's like call for paper deadline craziness. So there is like a lot of call for papers closing the 31st of January and first weeks of February. So I am in the same situation as Gerrit, like trying not to miss too many call for papers deadlines and
then waiting, crossing fingers.
Yeah, exactly. Yeah, exactly. I hear you. We have an event on February the 16th. We have the first 2023 Micronaut Foundation Town Hall. It's an online event. It's free. Please attend and stay on top of what's coming with Micronaut 4. We have also an in-person talk in the Oracle offices in Madrid by Álvaro Sánchez Mariscal. It's about Kubernetes Micronaut and implementing operators, Kubernetes operators with the Micronaut framework. So that's talking Spanish in person in Madrid, again in the Oracle offices. So hope to see you in the Micronaut Town Hall this Thursday. And if you are in Madrid, hopefully we can see each other on the 23rd for Álvaro's talk. We have published also several Micronaut guides since the last episode. We have published one guide about how to secure a Micronaut application using an API key. We have published another guide about how to configure a cross-origin resource sharing course in a Micronaut application. Moreover, we have a guide which is very related to today's topic, which is building a Docker image of your Micronaut application. And in that guide, we saw how to build a Docker image of a Micronaut application which uses Micronaut CRaC with Docker build CRaC. So If after the episode you think CRaC is interesting, please check out that guide and get started with Micronaut. I wanted to talk today with Gerrit and Anton about CRaC. So let's start by the name. So CRaC is an acronym for?
Okay, let me do that. CRaC stands for Coordinated Restore at Checkpoint, and a lot of confusing terms maybe just in the explanation itself. So we probably need kind of a big overview what can be improved in Java world and how we are going to do that. Probably closest analogy for that is a laptop that you always carry with you, and you always ready a lot of documents ready and programs open that you can jump to working with, and usually you don't see any problems with that. But once you have to reboot your laptop, it's a bit painful. You need to restart everything, to open a lot of documents and so on. So usually you don't have that problem because your laptop can be in sleep mode and everything is ready. But in JVM world, every JVM do a fresh start with every time you start a program, and that involves a lot of class loading, JIT compilations, probably components talking with each other. So for that, we are proposing a technology based on kind of snapshotting of Java virtual machine. And for that process, we call checkpoint and restore. Checkpoint is to store an image of a JVM, and restore is to get an instance of running Java from the image. And probably that covers two of three terms, but continue analogy with the laptop. Usually, you have everything you may need in the laptop itself. All the data, all the files, all the connections, and so on. So if something is missing during the time when your lid is closed, there is no problem. It usually handled in the usual way, just like hot plug connections, network connection slots, and so on. But for JVM, this is not the way we can really attempt to solve the problem. We cannot store everything in the image itself. It will be capturing the whole state of the world, probably with parts of operating system, with parts of network connections. This is not what we really want to do. So instead, for that, we are kind of open this abstraction. We are uncover the fact we are snapshotting and restoring from the image. We letting programs know that there is a checkpoint and restore phases or actions, and allow programs to react on that. This is what this coordination is for. To involve the program into the process of creating an image. So that's high level idea.
The problem that CRaC is trying to solve is startup time of Java applications.
Yeah, that's correct. Yeah, there are a few applications of the technology, and we usually look at that as a technology, but the primary action is indeed to improve startup and warm-up time.
Because you can tell me that you are like the experts in JDKs. Java as a platform and as a programming language, once the application is running, is fast. So there is no problems with the performance of... I mean, you just told Gerrit, like, you have like clients that use Java for trading applications, right? So it's not that Java is not fast when it's like running 24 hours 7, right?
No, that's correct. I mean, the problem is, as probably all of us know, is that when you start up, it's the JIT itself, right? So the whole process of JITting instead of ahead of time compilation or native compilation that you usually use when you create native apps. That the difference is that you gain some flexibility by using a JIT, where you can, during the runtime of your application, you can always optimize the code. But first of all, you have to compile it all and optimize it. And in the JVM, it's like first interpretation, and then it goes to the next level, which is the C1 compiler, and then from there to the next level, which is the C2 compiler. And not every code is going there. But once it reaches this phase, then it's pretty fast. The problem is getting there takes some time. And the bigger the application, the longer it can take. And this might be sometimes a problem. It's not for everybody a problem. In the past, where we have monoliths everywhere, it wasn't a problem to start the server, and it takes maybe 20 minutes to start it once, and then it runs for a month, no problem. But these days, where we have microservices everywhere, and then you would like to have them start them up as fast as possible, because sometimes they're short-lived. So it doesn't make sense to optimize it in the best possible way, just to run it for a couple of minutes, and then you have to shut it down again. So you lose all the optimizations every time you run the service. And this is the problem we try to solve, right? To keep the optimizations once you did them, and then run directly from there full speed. That's the main idea, I think.
Startup is not is still the important thing of in Java programs. I mean, we still need to optimize startup as well, because of all kind of serverless functions like AWS Lambda that is expected to be ready, but sometimes it's not, and you spend a significant amount of time just to spinning up Lambda service, and we are targeting this as well.
Yeah, absolutely. I think the startup time has limited places where Java could go, and nowadays those places are becoming more and more popular, such as serverless, or like Gerrit was saying, like you have like a small microservice that you need to replicate really fast. So yeah, absolutely. I think that Java can serve monoliths and microservices and serverless functions. That's great, at least for us Java programmers, so that we can keep using Java everywhere. So the laptop analogy, I think, is great. That's the way I picture CRaC myself. So it's like kind of you put the application to hibernate, and then the startup time is not like starting from scratch, but like resuming, right? So when like kind of like when you like hibernate your laptop and you resume, is really fast, and as you said, like when you reboot the laptop, is not as fast. So it's the same idea. I think that's a great analogy. So Azul integrates CRaC in the Azul JDK, or how does it work? So CRaC is only available right now in Azul JDK. What's the story around that?
But probably we can just break down the project CRaC as CRaC as a whole to a few projects. And one of the things you may think about, you may perceive CRaC as a JDK that implements this coordination and checkpoint and restore. And at the moment, it's available in or just open source builds of some JDK that can be downloaded from GitHub, run, and you can tackle and experiment with technology. Probably actually everyone is able to do such kind of builds. Azul, Gerrit team, anyone from those 20 Gerrit has mentioned. So yeah, this is one part of an implementation, and another part is specification and APIs that are crucial for this project, to people really be able and really use these APIs. And this part is more high level work that does not involve any implementation, and that is hosted in OpenJDK project and is developed under OpenJDK roof. So with that, it's actually not only many bundles of the same technology is possible, but also many implementations of the same technology is possible with the same API.
For people who don't know how the politics of OpenJDK works, myself included, is so you propose like you have this idea, right? And you propose it and it gets accepted as a project in OpenJDK, right? And if you go to wiki.openjdk.org/display/CRaC, you will find like the project is like a project in OpenJDK. And then the JDK vendors, they collaborate together to provide implementations of this idea. And if the implementations, they look promising, then eventually this may become like mainstream, or how does it work exactly?
How it will work, it's an open question. Yeah, we'll be only to look at that in the retrospective way. But you're actually correct. Yeah, there is a project is OpenJDK way to develop some experimental technologies that indeed may not be included in some in the mainline version of JDK, in some JDK version, but really what really work, and hopefully it will. But anyway, right, there is a project, a development branch when we collaborate with many folks, including Amazon, Red Hat, and to get this right, to get API working in a way that it is expected to get implementation to do what is reasonable in limitations, in some constraints, and so on. And as I said, we really hope it will be eventually included in one of the Java version, and probably Java major version. And probably it won't start with complete implementation. First, it may be just an API that may be implemented in different way that vendors or implementers may decide on their own, kind of like Java in general works. At first is a specification and a set of APIs that describe what implementation should do. And the implementation could be based on OpenJDK or not, so on. Yeah, during the time, we will start with APIs and implementation, and then we'll see.
And then I think the final decision is made by Oracle, right? So if it becomes really an official part of OpenJDK, like we saw with Project Jigsaw, which was for years, it was an OpenJDK project, but never really made it until they came up with the module system, which is based on Jigsaw. And then it became officially part of the OpenJDK distribution, right? So because there are a lot of these projects in OpenJDK that are not really part of the mainline OpenJDK, but they are just projects, like you said, like proposals for new features, and then it depends if they will be implemented or not. It's not really a decision of, you can take it as a vendor and do it on your own, but if you would like to become part of the official Oracle OpenJDK, let's say, then it needs Oracle to say that, right?
I'm not sure actually it's attribution by company, but as a general community, it's true that a lot of some major part of the community consists from Oracle folks, but I think in OpenJDK, OpenJDK does not distinguish really who works where. Just it's matter more of awareness of the project and so on. But yeah, it's true that many folks are really working in Oracle, and many folks who really do decisions.
So right now, CRaC is this proposal in OpenJDK, as there are many others. What you publish is like the API or a proposal for the API, right? As distributed to Maven Central or to GitHub packages, I don't remember. But there is basically the proposal of an API. But before going into that, we say like the advantages of CRaC is that it could heavily optimize your startup time of your application, because you are kind of hibernating and then resuming instead of like starting from scratch. What are the limitations? So what do developers need to think? Like, what do they need to think? What do you have to do before going into hibernate? Do you have to do anything at all?
Maybe first of all, we should mention that it's at the moment only available on Linux.
Correct.
That's a constraint that and you can't really, because there are people that really run Java on Windows servers, and asked for CRaC, and I said, sorry, you can't really use it. So it only works on Linux systems.
Why?
The technology we use in the background, which is called CRU, which is part of the Linux kernel, and because this is not really, it relies on the proc file system, which is not really part of, not of all this Linux distributions, but it's not part of the Mac OS, and it's not really part of Windows. So that's the reason you can't really use the current implementation of CRaC on Windows and Mac, which doesn't mean it wouldn't be possible. If there would be some mechanism that is approachable, then we could implement that. But so we are not really bound to this CRU only. So it's abstracted internally. So you can use different technologies. Even I think on Linux, there are other projects that do the same thing, like CRU does, but CRU is the most common one and I think the most stable. That's the reason why we use it. But this is one limitation you have to keep in mind. And the stuff that is available right now is also only on x64, so not on ARM. So if you run Linux on ARM, you also probably can't use it at the moment. That's the first constraints you have. And then there are others. Maybe Anton will explain that.
This is certainly true. And actually, we are working to provide more bundles of CRaC for different operating systems, or at least architectures. So, for example, ARM62 34 should be not that hard. There are a few places deep down in CRU that needs to be fixed, but that's manageable. Different operating systems are also problematic, but at some degree are possible. At least we can provide a part of CRaC implementation to expose the API to get you the same level of generic implementation. For example, everything except checkpoint and restore itself. Just for example, to you able to develop on Windows and Mac, and then be able to run on Linux. That's also manageable, and we are thinking about that and looking for a good and reasonable way to overcome those problems. But there are some prerequisites that are embedded in CRaC, and those ones that with which we are probably stick for some time. As I said, for CRaC, we provide coordination for programs, but coordination is not only an ability, but it's also a requirement. So, for example, since we cannot store everything from external world with a JVM image, we need somehow to deal with the links with that external world. I mean that what if Java program has opened the file before checkpoint, and the file is missing after restore? What is the correct behavior of standard library on implementation when the file is missing? For regular Java programs, it will be a real problem, just because something that should be there is not now. So to get some sense from the image, we require the program to close all connections to external world, to remove all the links. And this is a requirement on checkpoint time at the point when you're doing the snapshot. So if you're not obeying that requirement, the checkpoint is not created. It's something like safety mechanism that prevents you to get a checkpoint that won't run after some time on a different machine when the file is missing. Or, for example, if for microservice world, if a port that you're listening on is taken, we require no connections with external world, but provide an ability to restore these connections after restore. And in that way, when you will be restoring these connections, you will be able to handle all the exceptions, all the problems that are possible. So, for example, file is missing, or the port is taken, then I may take another one that is free. So I even may ask user for some input. What should I do next? And that is something that you should program in Java programs if you're going to run on CRaC.
So just to recap, limitations: you have to be on Linux right now, and your application has to close connections. That's coming back to what I was hinting before. So you provided an API so that people are able to say, like, just before you go to Hibernate, which is called before the checkpoint, right? I will close the connection. And then you provide also, the API provides like a Java method basically, which is going to tell you like just after the checkpoint, you can like resume whatever you have to resume, right? The API is as simple as I described. So there's like an interface called resource, and there's like a before and after method, and you override them and provide whatever you have to do. Sometimes you will not have to do anything after restore. Sometimes you will have. So another point is like the registration, right? So the order of this, so maybe you have to do more than one thing in your application, and those things need to happen in a particular order, right? And the part of the API is that you have to register these resources that you are writing in your own application.
Maybe I can jump in here. The idea is that you have a so-called context in the JVM. And then you have this interface that the API provides, which is called resource. And this interface you implement in all the classes where you have resources like external connections to the external world. And that means you implement the interface in that classes, and then you override the methods before checkpoint and after restore and do the stuff you have to do. And then you have to let the JVM know that this resource is there, right? You have to register this resource in the so-called context so that the JVM can notify this resource in case of a checkpoint and even after a restore from a checkpoint. That's the main idea of this registering, because if you don't do it, then the JVM doesn't know. Just implementing the interface is not enough, because then you have it implemented, that's fine, but in case of a checkpoint, the JVM does nothing because it doesn't know of this resource. So you register it at the context, and the JVM will let the resource know, now it's a checkpoint, it will call the before checkpoint method and so on, and after the restore is the same. So that's the stuff you need to do, exactly. And it's a static call on, I think, core.get global context, and then you get the context where you can register the resources. And as you mentioned already, the order might be important, right? So you might have a resource open like a database, which is used by another resource. So the database has to be open first, the database connection. That means if you close the resources, you do that in the reverse order. You registered them. And if you restore them, you do that in the same order as you register them. So to make sure that everything is always in the correct order in terms of the resources, how they are registered. That's the idea. I hope that was correct, Anton.
Yeah, certainly. I usually read the Java docs we have written for that to do that correct. One thing maybe worth mentioning is that you are free actually to implement context as you like. So you may decide the order. You may implement random order for some reason, for house testing, for example.
So I saw CRaC in a talk by Gerrit in JVC and Conf, and we had already been aware of the technology before and wanted to see how we could integrate into the framework. So what I would like to tell the people listening to the podcast is how can you use this nowadays in Micronaut? What we did is the following. So the API that Gerrit just described, it's published as any other dependency that you can install in your application. So you just have to add a dependency in your application. You could do the steps that Gerrit described. So you could create a class, implement this interface called resource, and then register manually those resources in the CRaC context. What we have done so if you go to docs.micro.io, you will find we have a dependency called CRaC. Everything that I am going to try to explain in audio format should be there in words and probably much better explained. So what we have done is, so when you are working with Micronaut, 99% of the time, you are creating singletons in your application, right? And you have like a class in Micronaut that is a singleton, is annotated with the standard Jakarta.inject singleton. So what we have created is we have an interface called order resource, which, as you can imagine, extends from the CRaC resource interface, which we just talked about, which has the before and the after method. And it also extends from a class that we have in Micronaut called ordered, which, as the name says, has a method called getOrder. It's a functional interface, so you can use that to essentially configure the order. So what Micronaut will do for you is you don't have to register your resources in the Micronaut. We will do that for you. One of the things that you have to think about is the order. So if your resources don't need any particular order, that's fine. Don't override. GetOrder has a default implementation. So if the order is not important for you, you don't care about it, then don't override that method. If the order is important for you in your singleton annotated, which implements order resource, then override it. So what we have done for users is they don't have to care about registering resources. They just add this CRaC dependency to their applications. They implement the order resource in the singleton that they need to do something special. Sometimes you will not have to do anything, because what we are doing in the library is we are providing resources for you. So for example, right now, if you have a Micronaut application which uses Netty, we have a resource already in CRaC which will take care of doing the necessary work to be able to close Netty and start netting properly. So we do that for you. If you are using, for example, microdata JDBC with a connection pool such as Hikari, that works out of the box. So you just add CRaC, and so you could have nowadays, today, as we are recording this, you can have like a Micronaut application with the Netty runtime, using typical persistent with microdata, with a repository pattern, using Hikari, which is probably one of the most common connection pools that Micronaut users use, and that will work automatically for you. We are working on providing integrations with other integrations. So the Micronaut framework has many integrations. We will have like around 50 modules or even 60 modules. So for example, today I was like checking our Gitter community, and there was like a user who wanted to use CRaC with Redis, and apparently it's not working. So probably we have to do something to work properly with Redis. So the goal for us is that this is transparent for you. You as a framework developer, as a framework user, you don't have to do anything unless you have anything custom, and you have to close any connection custom. But for most things, this should work out of the box without you needing to even create a resource for you. What else are we doing? So in my code, we have one. So I told you that 99% of the time you will be using singletons, but we have other scopes as other dependency injection engines, as you can imagine. So we have the prototype scope, but we have another scope which I think for CRaC is quite interesting, which is the add refreshable. So if you have a class, a singleton that sometimes you have to shut down and recreate, we have an annotation called add refreshable. And there are two ways that typically you can refresh those singletons. One is publishing a refresh event internally in your code. Another one is sometimes people expose an endpoint. So Micronaut endpoints for you coming from a Spring background is similar to the Spring Boot actuators. So same idea. So you can expound an endpoint called refresh, and when you hit that endpoint, a refresh event is recreated, and those refreshable beans are basically recreated. So what we have done, and this is something that you can turn off if you don't want this behavior, but by default, when you are using CRaC and beans annotated with refreshable, we will destroy those beans before the checkpoint, and they will be recreated the next time they are needed. So if we assume that that's kind of probably a desired behavior, that as I said, this is configurable. So if this is not your cup of tea and you want your refreshable beans not to be destroyed before the checkpoint, you can turn this off. Another thing that we have done is I am myself a macOS developer, and my colleague who has done most of the job, called Tim Yates, he's also working on Mac. We created a checkpoint simulator, so that in your test class path, you can basically call like emulate like a checkpoint, and you can see like you can test like your teardown logic is working correctly. So you can like emulate like shutting down and starting it up without doing the real thing. But for this kind of when you really have to write your own resources, this can be helpful to have like a test. So we have like the context emulator. But the most interesting thing and that we have in place is, so Micronaut is build agnostic. We support both Maven and Gradle, and you may be listening to this podcast and you may be thinking, okay, Sergio, but how can I try this? For real is, so we, both our build tools, they provide different packaging options, right? So let's talk with Gradle, but with Maven is the same. So with Gradle, you can, for example, you can have a Micronaut application and you can generate a fat jar and run it, right? With jar minus jar. So you just generate a Gradle shadow jar, you generate a fat jar, and you execute it. That's a runnable jar. Another way that you can do, and that's typical and it's becoming more typical nowadays, is you want to generate basically like a Docker image of your application and run the Docker image. And we have different flavors there, right? One of the flavors is same scenario. You just want to run a fat jar, but within a Docker image. And essentially what we will do is we will build the fat jar inside the Docker image, and the entry point will be just jar minus jar, right? Another scenario is, and for that we have like a Gradle task, which is called Docker build, and we have like a Maven packaging, which is equivalent. I think Maven package by default defaults to building like a fat jar.
Maven package minus d packaging equals Docker will generate a Docker image of your Micronaut application with Maven.
We have also for GraalVM. So Micronaut has a great integration with GraalVM. So if you want to generate a native executable of your application, you can do
Gradle native compile,
and that will generate like a native executable for your operating system. So that could be, for example, from macOS. But most of the times, your servers are running on Linux, right? So you don't want like a native executable for macOS. So typically what people will do is they will do like something like
Gradle Docker build native.
And what that will do is that will essentially inside a Linux, so it will inside a Linux, it will install Gradle Community Edition. It will install the native image component, and it will basically generate the native executable, and the entry point of your Docker image will be the native executable, right? So for CRaC, we have done the same. So we have Docker CRaC, and we have also like in Maven, we have a package, I think it's called Docker dash CRaC. And what we do is we take your Micronaut application, we use Linux, as you can imagine, in the Docker image, because it doesn't work in anything else than Linux. We install the Azul JDK, we generate a fat jar of the Micronaut application, we run it, so we do jar minus jar, and then we checkpoint it, and we give an extra option, which is we checkpoint it, and then when you run the Docker image, the basically the entry point is going to be the restoration of the checkpoint, right? So the execution of that Docker image is going to be much faster than the traditional fat jar, right? Because of the reasons that Anton mentioned. Another thing that we do for users is we allow them to create like a warm-up script. And this is probably something that you, Anton, or Gerrit can talk more about. But essentially what we allow the users is to provide a bash script that allows you to do like, I don't know, like send 1,000 requests against your Micronaut application before each checkpoint. Because that will impact potentially may impact favorably the performance of the restoration of the application, but that's probably something that you can explain better than me.
Yeah, the interesting part with CRaC is that it's so flexible. So it doesn't only solve the startup problem, which is mainly time to first response. But you can also use it to solve, or not to solve, but to get around the whole warm-up of your application. So some applications need to be warmed up before they are really fast. So then it's not really the time to first response that is important, but it takes some time, and companies run these warm-up scripts to like hammer the API with all kinds of calls to just make it as fast as possible, to touch as many code pieces as possible to get them optimized in the code base, in the compiler. And that's what you're trying to solve, or what you offer here. It's great because you can create an application that needs, or that really benefits from warming it up to full performance level, because then all the stuff is compiled as fast as possible. And maybe we have to just explain that shortly, because if you just run your application up to the first response, doesn't mean it's fully optimized, because there might be pieces of your code that never have been touched by the compiler, right? So that means if you would really have to have the best performance possible of your application, you need to touch as many code pieces in your application as possible by the compiler, right? To get it as optimized as possible. For that, some companies run specific, like you said, warm-up scripts to make sure that now this is really fast, the application is good. For example, trading companies, they need to warm up the trading application before the market opens to make sure that the code is optimized and fast as possible. So they have these warm-up scripts. And if you offer that before doing the actual checkpoint, that makes it possible to automate this whole thing, which is great, because this is something that we can't offer that, right? So it's cool that you offer this possibility for users to warm the application up before they actually create the checkpoint. This is really cool stuff.
Yeah, I would also just want to appreciate all the work that has been done to help users with CRaC. And as we expose, as you said, we are providing a package that allows you to use CRaC APIs on any HDK, actually, the one that does not even support any CRaC or expose any CRaC API or does not have any CRaC implementation. You moved further with that checkpoint simulators, and that's something we probably need to get in our in our JDKs as well. Have you considered to contribute that to OpenJDK?
So right now what we are doing in the bash script is quite naive. So as you can imagine, we don't know what the user's applications are. So by default, our warm-up script, I believe, just does a curl request and localhost 8080 to the root path. But as you said, if you know your application, right, tweak the warm-up script, call as many of your code paths as you can. That could help. So you are going to see a lot of improvements without providing any warm-up script. So what I encourage people to do is we are going to publish a Micronaut guide showing how they can measure the performance improvements of like the same Micronaut application with the different packaging scenarios that we described. Check it for yourself with your project. I think you're going to see like a much faster startup time without doing any warm-up script. But if you go the extra mile, both our Maven and Gradle plugins should provide you like an easy entry point to do that. And another thing that we have that I forgot is, so we have Micronaut CRaC, and then we have another project called Micronaut CRaC Test, which is where we have like our functional test for the integration. So I just described that we have like it works with Netty and it works with Hikari. We are working on some Micronaut supports other runtimes such as Tomcat or Jetty. So we are trying to work with other... basically, our goal is that Micronaut CRaC works with all the integration that we have. So it doesn't matter the technology that you are using. In an ideal world, us, the framework developers, should take care of doing the work for you of creating those resources that need to do the necessary work. And for you as a developer should be transparent. So if you are hitting so you are trying Micronaut CRaC and you are hitting any limitations, please let us know. Or if you have any feedback, please let us know. But we are really excited. I am really excited about CRaC and what's possible. I think this is gonna be another tool for developers to bring Micronaut Java applications to places that we couldn't be before. So we had a talk in a previous podcast episode with Mark Sales from AWS about the AWS Snapstart, which is, I think, is related to what Anton was saying. Is kind of another implementation of CRaC, right? It's not like the Azul implementation of CRaC, but this is kind of how they are using the same ideas of kind of hibernating and resuming a Java application in Lambda. And we are seeing excellent results there. And the great thing is they are using the same API as the one that you made public. So if you are using Micronaut CRaC, you don't have to change your code. If you are like working with Netty, then you can use Docker build CRaC and use the Azul JDK. If you are like taking that application and deploying to Lambda, the same code will work. As I said, it's a different implementation. So it's exciting to see in the JVM like different vendors using CRaC. Hopefully we can get some feedback from people listening to the episode and using Micronaut CRaC. What should people... so we told people about the limitations, that they have to be careful about open connections, currently works in Linux. What's next for CRaC from your point of view, and what should people get excited about? What should people be asking for?
Yeah, but as you can imagine, getting it to the next major Java version is what we are really targeting to. What is the next major Java version? It's an open question. It depends on when we all as a community agree that API is sufficient. It provides everything. Is there, and all the names are good, and that kind of stuff. And from the implementation point of view, we have few things that will not be covered by API changes, that usually internal changes sometimes. For example, we're thinking about how to improve this warm-up script. So, for example, if this is work-driven, exactly the existence of this warm-up script. When and how can we say that warm-up has ended for this particular JVM and it works in optimal performance? This is a research question, but we have some preliminary work kind of exposing some metrics that may help you to answer: are you ready for checkpoint, or you should provide some more workload and to get to better performance. There are a lot of interesting things we can do. I personally create small examples to understand how the technology behaves and what is missing there. So I see some spots for missing tooling, but probably I should let you to explore the technology and ask to allow you to ask for some tooling to compare our feelings, what is missing and what should be implemented next. But definitely we are going in many directions: API improvements, implementation, and in ecosystem. And you guys doing really great, and I really excited and impressed of the work that you have done. I see it really helpful, very important for technology like CRaC to start off.
So Micronaut is always, we are like always trying to be fast with a good developer experience. And we have done a lot of work on kind of like build time optimizations and things like that. And this is kind of another, as you said, this is another tool for developers, and quite excited about it. Do you have anything else that you would like to point on your side, Gerrit?
I just would like to point people to try it out if possible. So we need as many input as possible. So because we just provide the feature or the thing itself, but we don't know really how it will be used by users in the end. So that means always when I do a session about CRaC, then people ask, but can I do this? Can I do that? And I only can say, test it. We need this feedback because you have ideas. We just provide the tool, but you use it, right? And we need the feedback from you if something fails or not. It might be the same for Micronaut. So you need people to test that
absolutely.
Actually in applications. And then they come back with feedback like the Redis guy and say, oh, it doesn't work. So then you know where you have to work on. And this is the same for us. So people should just use it and try it out. At GitHub/CRaC, you will find it, and then you can just start from there. This is the only thing I would like to ask for.
We forgot. So you have like a GitHub organization called CRaC. So you go to github.com/CRaC. That's the GitHub organization. You will see like when we were working the integration, that was really helpful to us because you had like some examples about how to kind of do the things that we are right now doing in our build tools. Please try it out. It's really, really easy. So it's really to... I will include a link in the show notes, but we added so MyCode Launch is our project generator. So if you go to launch.mycode.io, we have like a button called features. Go there, select CRaC. You will see like CRaC, it says preview, but actually we released already like a GA version of the module. Click generate project, go and do like Docker CRaC. And if you select it, if you select it, maybe do like package Docker CRaC, and you will have like your first MyCode application checkpoint in hopefully in seconds. So try it out, please. I see many scenarios, as Gerrit was saying. I see like people using like container as a service solutions such as AWS Fargate. This would work fantastic, or in Google Cloud Run. That should work really, really well as well. So yeah, please use it. Please give us feedback, and hopefully we can, given that feedback, we can create more documentation and more tutorials about how to use it and keep improving our integration. But yeah, excited, and thank you both for taking the time to talk to me today. Anything else that you would like to point before we wrap up?
Nope.
From my end, I'm gonna thank the sponsors before I forget. So many thanks to the MyCode Foundation sponsors for sponsoring the MyCode Foundation, which is a foundation which helps not just develop but also promote the framework. So kind of what Gerrit and myself do, a lot of advocacy. So we have corporate and community sponsors. We have Object Computing, which is an ambassador sponsor of the MyCode Foundation. MicroStream, where we have also like an integration with MicroStream, which is a really exciting persistent technology on the JVM. MicroStream is a silver sponsor of the MyCode Foundation. We have the people from Safri.net, from Visor Games, -Q. Those are bronze sponsors of the MyCode Foundation. Oracle is an engineering partner of the MyCode Foundation. And Gradle Enterprise and JetBrains, who are tools partners of the foundation. Many, many thanks to all of them. Without the sponsors, the foundation will not be possible, and my job will not be possible. So many thanks to all of them, and many thanks also to the community sponsors, to individuals that sponsor the foundation. And again, thanks to Azul for borrowing me, Anton and Gerrit today to talk to me. Thanks for listening to the podcast, and we see each other soon, hopefully. Thank you.
Thank you.